Thanks again for joining our MOLYKOTE 101 webinar series. Today we'll be covering pastes, what they are, how they differ from grease, and when to use them. As well, we'll be covering a brand new product, the P3700 paste, that provides true premium performance as well as a completely hazard-free label. Our speakers today are two of the brightest minds on the DuPont team, William Fick, a Lubricants Application Engineer, and Melissa Mushrush in Product Development and R&D. Without further ado, take it away, Will.
All right, introduction to paste. For part one, introduction to paste, we're going to be going over how greases and pastes differ. What are the primary solid lubricants in a paste? What are some of the potential failures? We'll also take a look at MOLYKOTE paste and formulation options, and then we'll go over the foundational products that MOLYKOTE has to offer. So for an overview on paste, I'd first like to take some time to kind of address MOLYKOTE as a whole. MOLYKOTE's a lubrication company. We have 6 different product families, as you can see on the left side with our MOLYKOTE wheel. We have greases, pastes, oils, compounds, dispersions, and anti-friction coatings. In the center of that wheel, you can also see that we list off some of the functions of lubrication, things like separating the surfaces, reducing wear, and managing coefficient of friction. Also, some important notes in there about identifying your application, which is very critical. For this, we use load, environment, temperature, and speed, otherwise known as our LETS acronym. On the right side, we have boundary friction, or the 3 friction regimes, starting with boundary friction. Boundary friction is where you have your high loads and slow speed applications. Maybe think of something like a press fit. This is the area where you'd use things like paste or anti-friction coating, something with a high number of solids to reduce wear. On the other end, you have hydrodynamic friction, which is your higher speed applications with lower loads. At this regime, you have a separation of surfaces due to lubrication. These lubricants used on this end are usually things like oils or greases. And then in the center, you have your mixed friction regime, which would be where you want to use things with solids in them, but still grease. So like greases with solids, grease paste, dispersions, and oil. These are, at this regime, you'll have mostly fluid separation, but you have the occasional asperity contact where you need those solids to kind of protect your substrates. Let's get into paste specifically. First, looking at the greases or the paste appearance and how they're similar to a grease. So you might look at a paste and say, wow, this really looks kind of just like a grease does. Although they really look similar, they're in many ways different. Pastes have little to no thickener, whereas a grease has a thickener as its second most plentiful ingredient. They look similar because a paste is comprised of primarily microsolid lubricating particles. That high number of solids really gives it that high consistency appearance of a grease. On the left, you can see that we have MOLYKOTE DX paste. And on the right, there's a MOLYKOTE GN metal assembly paste. And as you can see, they do look very grease-like. So let's take a better look at the differences between pastes and greases. The first thing you may notice is that a paste has far less base oil than a grease does. That's because in a grease, the base oil is what does the primary bulk of the lubrication, compared to a paste where the solids do the lubricating. The primary reason for base oil in a paste is simply to carry those lubricating solids to the point of lubrication. Think of a school bus, or in this case, the oil that's delivering the solids, or in this case, the kids to their home or wherever they need to be. Once the solids are in position and they're burnished into the substrate, they'll remain there even after the oil evaporates or runs off, or wherever the oil may go. For the conditions that may fall in between the strengths of a grease and a solid, we have, or a grease and a paste, we do have things like greases with solids and grease paste, which excel in those mixed friction regime areas. You can also see that we have a product listed on each one of these bar charts. Live is an example of a MOLYKOTE product that falls in that category. For paste, we have the 1000 paste. For grease paste, we have P1042. For greases with solids, we have the BR2 Plus, and then for a simple grease with no solids in it, we have the MOLYKOTE 33 Light. So again, greases and pastes may appear similar. However, they're used in many different applications. Greases are used usually better in high-speed applications. Paste are usually better in high-load, lower-speed applications. Greases have a smaller temperature range because the base oil can freeze or evaporate. So that limits it a little bit. But a paste has solids for lubrication. So once they're burnished in, it doesn't really matter what happens to the oil, so you can get higher temperatures. Greases can also be displaced by excessive force, which leaves no lubrication behind, versus a solid, again, can get burnished in and stay in place even after high loads are applied. With the paste, you also get much higher oxidation temperatures. Pastes are also gravity resistant. Greases can run off due to gravity, and then you again lose your lubrication versus those burnished in solids, which will remain there even if they're upside down. It really doesn't matter. To summarize, again, pastes are great in these static, low speed type of applications with high loads. Solid pastes have also like a load range where they're optimal. They reduce friction best at specific loads. PTFEs excel in low load situations, followed by graphite, and then MOS2, which has the highest load carrying capabilities of the solids in our paste. Combining different solid lubes, you can expand load ranges for applications if desired. The image on the left shows some solids. In this case, they're anti-friction coating solids that are on a substrate. As the substrate kind of wears through these solids, you'll see a huge spike in friction, up to what you would expect to see for metal on metal friction. You can see in the plot on the right that there's a red line which represents the PTFE. It has a great coefficient of friction at these low loads compared to the MOS2, which is in blue. However, once you approach the 85 kilogram mark in this test, you start to see it kind of start curling upward. This indicates it's starting to fail. And eventually it'll reach that metal on metal coefficient of friction that was discussed before. From this point on, though, you can see that the MOS2 continues to decrease in its amount of friction as load increases. That's why these LETS conditions, or load environment temperature and speed, are critical to know. Selecting the proper paste for the desired application is critical for the life of the product. So here we can see some of the types of fastener failures with a brief description for your reference. Galling is when two surfaces cold weld together due to extreme pressures. This is most common when stainless steel nuts and bolts are used without proper lubrication. You can see in the first image that there's pitting due to these cold welds. As the material cold welds together and the bolt is tightened, the material kind of breaks apart from itself, causing these pits. Then we have shearing. Shearing happens when the torque results in fastener twisting. This can cause high friction between surfaces, which results in seizing. Once the shear strength of the material is passed, the fastener will shear. And you can see in the second image an example of what this shear failure looks like. Then we have fretting. Fretting is due to vibration. So as the materials kind of vibrate against each other, they vibrate through this oxide layer, causing corrosion. You can see in the third picture that it's kind of starting to form around that bolt hole. And then the last image just shows some pitting and microcrack propagation. This can continue as pitting occurs. Pitting will happen. You'll see these cracks form, and then that piece can flake off, and you'll see a kind of growth of pitting as it kind of makes its way across the substrate. So all of these really can be avoided with proper lubrication. So lubrication is key here. So let's look more specifically at MOLYKOTE Paste as a whole. MOLYKOTE Paste are really a premium product. We have a high level of lubricating solids. These solids help customers protect their equipment against galling, stick slip, fretting, corrosion, and other types of failures. With a wide breadth of different paste and product offerings in general, MOLYKOTE can deliver a solution for every problem, whether it be related to harsh environments or even sustainability goals. From consistent coefficient of friction, water washout, protection against corrosion, MOLYKOTE pastes are designed to excel in these low-speed, high-load applications across a wide range of different temperatures. When it comes to formulation options, there's certainly no shortage of combinations. For base oils alone, we have mineral oils, polyalpha olefins, polyalkylene glycol, silicone, plus some. On the solid lubricant side, we have MOS2, graphite, copper, white solids. just to name a few. White solids can be broken down and even further into many more different options. Remember, these solids are the part of that formulation that are most critical for your coefficient of friction and your wear protection. Then we also have additives, which can be added for specific requirements. If you have something that needs additional corrosion prevention or needs to be really tacky, there's adhesive additives, and then even extreme pressure for those applications that need even higher loads. When formulating a paste, it's obviously not a one size fits all for every application. One application might excel with a certain paste where it might have characteristics that are a detriment in another application. This is why, again, the LETS properties, our load, environment, temperature, and speed, are very important when selecting a paste. So let's break it down into some foundational MOLYKOTE paste. The MOLYKOTE paste product portfolio can be pretty overwhelming, which is why we came up with these 4 basic pastes to use as a starting point. These can address about 80% of all the applications that you may run into. For the thread paste, we usually start with 1000 paste or the P37 paste. The 1000 paste is great for many threaded connections, but we do recommend the P37 paste when extreme high temperatures are being used, especially with materials such as stainless steel and other exotic metals. For lubricating paste, we usually go to our GN metal assembly paste or the MOLYKOTE DX paste. The DX paste is great for vibration due to its ability to reduce fretting. And then the GN metal assembly is a great load carrying paste with very low friction. We do understand that there may be applications that these 4 don't cover. So for these other 20% of applications, we can reach into our robust portfolio and find a good fit for your specific application. It's also worth noting that our products all come in a variety of different package sizes to meet your needs. We have drums, cans, tubes, aerosol sprays, even really a size for everything. So let's look at these 4 products in a bit more detail, starting with the GN metal assembly paste. This paste does an exceptional job at reducing friction, wear, and corrosion for various equipment, especially during assembly, running in maintenance. Some applications it's suitable for include things like braking in splines, gears, tracks, cams. It's also great for lubricating conveyor tracks, chains, gears, and threaded connections, and fantastic for things like press fitting, cold extrusions, and general part assembly. Here you can see some of the typical properties of GN metal assembly paste, along with some key points. It's a great paste for preventing seizing, galling, fretting, and corrosion. It does all this while maintaining a consistent and low coefficient of friction. There are some other MOS2 containing products that exist in our portfolio. Another popular one is the G-Rapid Plus paste. MOLYKOTE DX paste is another core product that's frequently used. The DX paste does a great job at lubricating sliding surfaces, things like pins, rails, guides. It can also be used for threaded connections, plain bearings, and power screws. Again, we can see some of the typical properties just for your reference. This time for the DX paste with some key points. DX paste prevents stick slip, seizing, and provides great protection against galling. It stays in place with no drip or run, and it has fantastic water washout and spray off characteristics. MOLYKOTE also has other products that contain white solids, including the P40 paste V1, as well as the P74 paste. The MOLYKOTE 1000 paste is one of the go-to thread pastes, as I said before. It's well suited for threaded connections and bolted joints, especially those that are exposed to extreme environments. It can also be used to lubricate things such as rollers, hinges, and outdoor equipment. You can check out some of the typical properties for MOLYKOTE 1000 paste here. One thing to highlight is its unique composition. It utilizes copper, graphite, and white solids. And with this synergistic composition, it can provide great load carrying properties while maintaining a low coefficient of friction. Even after the bolts are loosened and retightened several times, it can do this and protect against fretting, wear, corrosion, and other important features for threaded fasteners. MOLYKOTE has other products that contain copper. These include the CU 7439 Plus Paste V1 and more. And then finally, for the 4 go-to products, we have the MOLYKOTE P37 paste. The P37 is also ideal for threaded connections. The typical properties for P37 can be seen here. This paste utilizes zirconium dioxide, which is one of the white solids we discussed, that we previously discussed. Things that make P37 special is it contains a low halogen and sulfur content, which helps reduce hydrogen embrittlement and stress corrosion cracking in stainless steel and other highly alloyed steels. These, the type of substrates that have small grain and tight grain boundaries. It also has great load carrying and contains no nickel or other metals that may contribute to solder embrittlement.